everybody. Today our learning objectives are going to be define the term multiple allelism, to determine the blood group from a genotype of a certain individual, and to specify genotypes of blood groups of individuals from their parents or their children. Our subject today is going to be about blood groups and codominance. Blood groups actually is determined on chromosome number 9. If you examine here, chromosome number 9 is as any other chromosome out of the 23 kinds of chromosomes in humans. It's divided into many partitions that we call gene. And you know that each gene is specific to one and only one trait. For example, here in the first gene on chromosome 9, it's responsible for albinism, which is the absence of skin pigmentation. Here on this location on chromosome number 9, we have a gene that is responsible to determine the blood groups in humans. To recall together, all the traits that we studied so far were traits that have only two alleles in nature. For example, the trait earlobe has two alleles, free and adherent, and nothing else. Actually, most of the traits in humans, animals, and plants are traits that having in nature only two alleles. But in reality, there are certain traits that have more than two alleles. These are called multiple allelism. Multiple allelism is when a certain trait has 3 or more alleles in nature. For our example here, for blood group, there are 3 alleles, which are allele A, allele B, and allele O. Let us see how these 3 alleles work in nature. Actually, these 3 alleles, we can determine 4 blood groups from these 3 alleles in humans. For allele A, actually allele A is dominant over allele O, as well as allele B is dominant over allele O. So A and B are dominant over O, so O is recessive. But when allele A present with or coexist with allele B, both of these alleles are going to be expressed. So they are codominant with respect to each other. Here, again, I have chromosome number 9, and we have presented many of the genes on this chromosome, but what I'm concerned about here is a gene number 6, which is responsible to determine a blood group. They have mentioned that for a blood group we have 3 alleles, allele A, allele B, and allele O. But you know that each individual has two chromosomes number 9. Why? Because we got one chromosome number 9 from our father, so it is of paternal origin, and one chromosome 9 from our mother, so it is of maternal origin. Now on these 2 chromosome 9, actually we are going to have 2 alleles. Although we have 3 alleles for blood group in nature, which are A, B, and O, but each individual has the possibility of having maximum 2 alleles. But these 2 alleles may be the same or may be different. How? For example, I can say that there is a certain individual has 2 alleles A. So he got one allele A from his father, another allele A from his mother. What would be the blood group of this individual? He is going to be of a blood group A. So his phenotype is blood group A. Maybe in other case, another individual has 2 alleles A and O. A from his father and O from his mother. or the opposite? Actually, since allele A is dominant over allele O, so this individual is going to be of blood group A because allele A is going to mask allele O. For group A, for a person to be of blood group B, he is supposed to have either two alleles B, so he got one allele B from his father, another allele B from his mother. Or another possibility, he has allele B and one allele O, so he's going to be of a blood group B again because allele B is going to mask allele O in this case. In another situation, if a person has two alleles, two different alleles, allele A and allele B, so he got one allele A from the father and one allele B from the mother, his phenotype or his blood group is going to be AB. When an individual is going to be of a blood group O, only in one case, when he get allele O from his father and another allele O from his mother. Since allele O is recessive, so it cannot be expressed unless it is alone. Here, I have organized a table for you to determine for each genotype the phenotype of each individual. If the genotype of the individual is AA, so he is going to be of a blood group A. If his genotype is AO, so his blood group is going to be A. But if he has a genotype BP or BO, his blood group is going to be B. When he has genotype OO, when he gets one allele O from his father, one allele O from his mother, so he's going to be of a blood group O. And he's going to have blood group AB if he has genotype AB. Let us see in this example what we have. I have in this exercises Ali is heterozygous for type A blood. When I say type A, meaning blood group A. And his wife Maryam is heterozygous for type B blood. So Ali is of a blood group A, his wife is of a blood group B. But they mentioned that both of them are heterozygous, meaning that Ali genotype is AO, while Maryam genotype is going to be BO. They are expecting a baby, meaning that they are going to give birth to a new baby. The question is, make a factorial analysis to determine the possible blood group of the baby. Here we can start doing our factorial analysis as usual, starting with the phenotypes of the parents. The parents are of blood group A and B. What the genotypes of the parent are going to be AO for Ali for the father and BO from the mother. The gametes produced from these parents, from the father I'm going to have 50% of the gametes containing A allele, 50% of the gametes containing O allele. While the mother, 50% of her gametes are going to carry B allele and 50% of her gametes are going to have O allele. If we're going to draw the table of cross in this case, we're going to notice that the possibilities of the genotypes of any baby that is going to be born for this family are going to be AB 25%, BO 25%, AO 25%, and OO 25%. Pay attention here that OO, both of them should be small letter because O is recessive. And if you notice that A and B are capitalized because both of them are dominant over O and both of them are codominant with respect to each other. So what are the possible genotypes of the baby which is going to be born? The possible phenotypes of the coming baby are going to be 25% blood group AB, 25% blood group B, 25% blood group A, and 25% blood group O. So this baby of this couple has 4 possibilities for his blood group. But actually, he's going to be one of them, but we don't know which one of these 4 blood groups the baby is going to be. So he has 4 possibilities. But notice here, from a parent having blood group A, from another parent having blood group B, they can give birth to a baby of blood group O. And some people are astonished of some of this fact if they don't know about heredity. How it comes that 2 parents of a blood group A and the blood group B can give birth to a baby having a new blood group which is O. Actually, this is because both of these 2 parents are heterozygous, so they are carrying O allele, but it is masked, so they can inherit it to their child, so it's going to be of a blood group O. Let us see if you have understood this part. I hope that you have to practice more now. For this exercise, we have Hadi is homozygous for type A blood, and his wife Sarah, who is heterozygous for type B blood. They have 1 child, Hussein. The questions of this exercise: 1, you have to draw a pedigree for this family. 2, you have to make the necessary factorial analysis to determine the blood group of Hussein. Please do this exercise, and you can send it on WhatsApp, or you can send it as an attachment in the library or the agenda. Till I meet you another time, please stay home, keep safe. Ramadan Kareem.